Continuing on to page 4, we're going to answer questions about electrochemical cells. In question 16, they ask us about the change in the oxidation state of zinc. So here we find zinc here on the reactant side and here on the product side of the equation. Now on the reactant side, we notice that zinc is in a solid state all by itself. So the oxidation number of zinc here is 0. Now in the product side, we see that zinc is with 2 other elements. Since this isn't binary, we should refer to reference table E to find the polyatomic ion here. On reference table E, we'll see that the polyatomic ion we're looking for is here, sulfate. And sulfate, as a collection of 5 atoms, 1 sulfur, and 4 oxygens, has an overall charge of -2. That means that we can refer to our reference table to find the charge of zinc. Here we see that zinc can only have a charge of +2. So the oxidation state of zinc goes from 0 to +2. The next question asks about the operation of a voltaic cell. Now, this is a simple definition equation, and we know that voltaic cells are spontaneous reactions where chemicals are turned into electricity. The next question refers to this diagram of a voltaic cell. Remember, we can tell that it's voltaic because it has a voltmeter, a salt bridge, and 2 separate containers. The first question asks, what is the total number of moles of electrons needed to reduce 6 moles of nickel ions? So for this, what we're going to want to do is write half reactions to figure out how many electrons are changing here. So to write a half reaction, what we're going to do is we're going to write the elements separated by an arrow and only show how each element changes individually. So in this case, we'll start with nickel. And when we look into our reaction, it's halfway done for us. We see that nickel starts as an ion and finishes as an atom. So what we're going to do is we're going to write nickel, and we'll write its 2 oxidation states. So it starts out as +2, and it ends up as 0. And then we'll write magnesium. Now magnesium, on the other hand, is starting out with 0 oxidation state and ending up in its ion +2. So we see that these 2 reactions are balanced according to atoms. 1 nickel, 1 nickel, 1 magnesium, 1 magnesium. But they're not balanced according to charge because +2 does not equal 0 and 0 doesn't equal +2. So to balance these reactions, what we're going to have to do is place in the electrons. So to do that, what we're going to do is we're going to add the electrons to the more positive side. So 2 electrons will be gained by the nickel ion, and 2 electrons need to be lost by the magnesium atom. So we know that each nickel is going to have to gain 2 electrons. This sets up a simple stoichiometric relationship. Again, rewriting the half reaction for the nickel only, as that's the only thing we're really concerned with here, what we have is that 2 electrons must be gained for every nickel. But the question says, well, how many moles of electrons are gained when we have 6 nickel? So if this is 6, what is this? So we set up a nice simple proportion and we solve, and then we're going to get that x equals 12. The next question has us referring to reference table J. Let's pull it up. And here we're looking for an atom that is more easily oxidized than magnesium. So let's first find magnesium. This is magnesium. Now, remember that magnesium is here under the metals column, and metals tend to lose electrons. So we're looking for a species that is a better loser of electrons than magnesium. So in this case, any of the elements that are above magnesium would qualify. So here we'll just pick one. I'll pick potassium. The final question asks, what's the function of the salt bridge in a voltaic cell? Well, remember that when the voltaic cell operates, the electrons are going to travel from the species that is oxidized to the species that is reduced. So in our case, we see that magnesium is a better loser of electrons than is nickel. So the electrons are going to flow from magnesium through to nickel. Now remember, to determine the flow of electrons, always refer to reference table J and don't just assume that electrons move from left to right. So the electrons are moving from left to right. Now, for electric current to flow, we're going to have to complete the circuit. Now, only electrons can flow through the wire and through the electrodes. So what's going to happen is that ions, negative ions in this case, are going to have to continue flowing through the salt bridge to complete the circuit. If ions do not flow after the first electron is transferred, the circuit will stop. So remember that this path I'm highlighting is the path of the negative charges. First it's the electrons, and then it's the negative ions, called the anions, through the salt bridge. Now, of course, the salt bridge contains two ions. It contains anions, which travel towards the anode, where electrons are lost, and it contains cations, which will travel towards the cathode, where electrons are gained. This helps maintain the charges of the electrodes and continue the flow of electricity. The next question is a reading passage, and it asks us to write a half reaction that represents the oxidation of copper, where copper